Hi explorers, and welcome to another video. And today we're going to talk about convolutional neural networks. And convolutional neural network is something that we use to identify things. And it's often used in image recognition, but could also be used to find patterns in really large data sets. But as an exercise, it's easier to explain it with images. So that's what I'm going to do. And to start off, a convolutional neural network could be seen as something modeled on our own brain, because we have a lot of neurons that take stimuli from either our hearing or our sight or taste and so on. And by these different signals, we will decide on a specific view on the world, and we will understand the world from the different senses that we get. And in a neural network, you can take an image like this one. It's a very simplified image. I tried to draw an E. So you see the ones here is in a pattern of an E, and then you have all the zeros, non-activated areas around it. And the neural network will look in this image for patterns. So let's say that we look at the little bit smaller piece of the image, and then look at this part here. Then we will see some kind of an arch or a curve, or perhaps even two straight lines that was found in this part. And if we then take and stride one over, so we will look at the part from here. So we will look at this rectangle, then we will see a longer part, but much fewer zeros around it. So we will identify this part as something, and then we take one piece over more, and we'll see that the line ends over here. So here we have just a line. We record all of these results that we see, and then we move down and look at this part over here, and so on. We go through all this. And that, what I explain now, we take a stride of one, we say. And that will give us a lot of information about this image that we could put into a new network. So let's say that we found this here, and we call this this thing that we found a 1. Let's say that's the 1 figure. And when we come to this box here, we see this here, and that's a 2 figure. And then we have this line over here, that's a new figure, 3. And then when we come to this is something new, so that's a 4. And we go on and identify different figures and just give them a number or a specific kind of filter that could recognize this type of thing that we saw. We don't know what it is yet, but we can recognize that kind of a thing again, or that shape again. That's the important part. So when we have this network that could recognize specific shapes, we could use this for instance to recognize a little bit more different shapes. So let's say if we have a circle and we put it into 4 parts, then we can say that with all these strange patterns that we found, we can say that, okay, we have a lot of patterns here that looks somewhat like an arch with this curvatures, and then we have this arch over here that looks something like this with this kind of an angle, and we have an arch over here with this kind of an angle, and so on. So we will identify these arches as different entities as well. And let's say that this image is much more a lot more intricate. So I will try to draw this strange shape here. I wonder what the computer will say about this strange shape. Here we have the circles we talked about earlier that we had identified, and we will probably identify something up here as some kind of shape. We have a line in this area and so on. So we will have a lot of filters that find different objects in an image. So let's say that with the first part of our neural network, we had a lot of neurons that found ones and zeros in one part, and then we have another filter that found them in another one, and these are interconnected to new neurons that they will give weights to, and these weights will tell it that it's either a circle or it's a straight line or it's some kind of this curve over here, and this will tell new neurons that, well, this kind of curve over here is a part of a circle, and this curve over here, that's a part of a roof or whatever. And then we go even further to another layer over here, a few more neurons, and those will say that, well, this is a back part of something and this is a front part of something, and so on. And then we last in this neural network, we will have some neurons that are fully connected. So every one of them have weighted pairs between them, because the first of these is a lot of filters to find things. And then we slim our network down so it will be lighter and lighter. We can make even more neurons over here to illustrate this bit more. That it's a lot of things in this end, and then we slim it down until we get to a point where we have a fully connected network where the output that we know that we have, let's say 4 outputs. It could either be a car, a dog, a cat, or a zebra, let's say. And we know over here that it's not a dog. Probably not a dog. It doesn't look like a dog. Zebra? No, doesn't look like a zebra either. I can't say. Is it a cat? Nah, probably not a cat either. So it must be a car. And in our training set, we have a lot of pictures of cars. So we can definitely say that this is a car. And when we have found that this is a car, we do as we did in our previous examples with the networks, that we go back from this point here and say, this is a car, this is not a dog, it's not a zebra, and it's not a cat. And then we change the weights backwards. So this fully connected network will change all the weights to weight more at a car for this specific image. And then we will go back and do the same for all the other networks in our series until we get to the point where we have the weights from the first neural network that found shapes. And often when you do image recognition, you have some neural networks that have already been trained with a lot of shapes and a lot of things. So often these layers are so good at finding circles, finding arches and so on. So these layers seldomly change, but the later layers will change because your problem domain is a bit different than anybody else. And then we have a little bit of a twist here. We could get a network that is great at finding cars. It's so good at finding cars that when it sees a specific new zebra that it's never seen before, it says that it's probably could be a car, but I can't say that it's a zebra at least. And we can't find a way to get it to a zebra result because it weighs too much to a car result. Then this is probably overfitted. It's too good to find cars, and it could be bad at finding other things. So then you can have a neuron in here somewhere that's also connected with weights, and you say that this neuron, it has no weight. So from this neuron, it's always 0. And in this net that we have over here, that's a dropout net, and that will drop some of the neurons out at random, just to remove some of this overfitting results. And so the neural network will be good at finding things, but not too good, so it can't recognize new images that you give it. So that's something that you always have to keep in mind, that you could train a network to be really good at finding things, but if it gets too good at something, it will not figure out a result for things that it haven't seen before. So that's pretty much a simple explanation how convolutional neural network will work. I will go into more detail on the different parts in later videos, but this is a high-level overview for introducing the concepts. If you have any suggestions of things I will talk about when it comes to convolutional neural networks, please tell me in the comments, and I hope you found some interesting concepts in what I talked about, and that you learned something, and I really hope to see you in the next video.